Hello and welcome to our 10 years anniversary series of our HPCC Systems podcasts. As you are well used by now, we have great people from the community that are joining us for a conversation, a casual conversation on the happenings over the past several years in the community. And today is no different. Today we have two professors in Oxford University, in the Department of Mathematics. They have been instrumental to expand our academic program to universities that are, as you can imagine, very well known and very renowned in the UK. They have been doing great work with a student who has been doing her PhD program and touching aspects around epidemiology, statistics, mathematical models, economical models and financial models, and many of these models related specifically to the impact of pandemics. So it is, I think it's a very timely type of study. But it's also quite interesting because it expands beyond what the typical type of research that is done in HPC systems. So first of all, welcome. We have Professor Ning Wang and Professor Hanqing Jin, who have been part of the community for several years now. And we have had regular conversations for years, monthly conversations. So welcome and thank you very much for joining me here.
Thank you for inviting us.
So let's start from some remote times. This sounds like now ancient history, but Ning, tell us a little bit about you and perhaps how you got into getting into HPC systems and to the community and how we met and etc.
Yeah, thanks. First of all, thank you very much. Thanks for the invite from HPC Systems, especially Flavio Villanustre and Lorraine, and thanks for organizing this fantastic podcast. A little bit information about myself. Actually, I'm one of the data scientists working at the Mathematics Institute. So I'm not a mathematician, but I know a little bit more mathematics than the computer scientists, but if you compare to the mathematicians, I know a little bit more programming than the mathematicians. So I'm the people in the middle between data science and mathematics. So, and I work in the math department Oxford since 2014, and we established a financial big data lab, Oxford-Nie Financial Big Data Lab in 2014. So that it was probably the first labs in the area of financial big data in 2014. So I got my position there as a data scientist, and so especially tackle the problems because our lab is also collaborate with the math finance group in math department. So it's originally most of our faculty is from also the colleagues they are from math finance backgrounds. So probably I'm the only person from data science backgrounds. So we want to tackle some problems between finance and data science. You know, the big data is a revolution in these areas, especially so we got the mobile phones, internet, and IoT's Internet of Things, smart cities generate a lot of data. And that things also happen in finance. We know the trillions of data, records of data generated every day, maybe every hours. And how to better use that data, tackle the problem of that data in the area of finance, that's a big problem. And we are facing that kind of problem because originally, most of the people in math finance, they are doing mathematicians. They are mathematicians. They are doing some modeling, for example, quantitative finance. Most of them, our work originally from mathematical point of view, and now we want to shift from mathematics. viewpoint to data science point. And for more specifically, it's we are looking at some techniques, for example, machine learning, deep learning, statistical analysis, and try to apply the state-of-art machine learning technologies in the areas. And so of course, my daily job, I need to tackle with a lot of data. So data is the key in these areas. And I came across HPCC Systems. I think I remember maybe 2006. If you correct me if I'm wrong. So I met Flavio in China. It's a Big Data Expo, the conference in Guizhou, Guiyang. That's a fantastic. I think the highest levels conference, the biggest conference in China, and so China is a big player. They have the huge ambition in this area. It's a big
and one of the biggest conferences. Sorry to interrupt, but one of the biggest conferences in the world, probably. Yeah, if you look at the size of the conference and the exhibits.
At the same time, I just saw the news because they had the 2021 one in Guiyang at this moment.
Oh,
I think. Yeah, I think every year they have this annual event. So every June they have this conference. Right? I met Flavio in China. I think 2 years ago or 3 years ago in China, and we chatted a little bit about HPC. It's a fantastic, very interesting systems, and it's a kind of system we're looking for because we have our own server, and to build hardware is very easy. You just buy some server, but to get some software is quite hard. So it's a huge gap, especially I know there's some open source platforms, some package, Python package, and a lot of, for example, some cloud-based systems. They have some little bit data analytic functionalities, but it's quite hard to use. I didn't see any integrated systems can combine the platforms, data, algorithm, everything in all together. So it's a very easy user interface, and so you can get your hands-on experience just straight away. And so that's a kind of system. So I chatted with Flavio, and we found some common ground. I think we must have some collaboration because we need the system, we need some data, and also we have master programs. We have some students, and master program is shifting originally from the modeling trends. Now most of students they're looking for some data science approach, and they're keen on learning some technique, latest technique in data science and the platforms, programming languages, and the machine learning, deep learning. All this technique is quite useful for all of them. So I think that's a kind of explanation. I just want to keep it short. I think it's quite interesting systems, and we've been using the system for over 1 year, and we love the systems. I think it's a fantastic thing. It's helped us quite a lot in terms of tackle the problems in big data.
I think that was a great way to bring everyone to context on of course, involvement in Oxford and the Institute of Big Data, but also the participation on the HPC Systems community as well. So, Hanqing, can you tell us a little bit about you and how you got to get into the community?
Yes. So thank you for inviting me for this event. So I'm Hanqing Jin. I'm working in mathematics finance. My own expertise is originally on the decision making, something like how to do the investment in some optimal way. This is my background, but I think it's just from 2012 or 13 when the topic of big data beginning to be very, very popular. Our community, in the mathematics finance fields, will be something like affected very much, and this is why we started our Oxford-Nie lab, on financial big data. So we want to see how this data-driven or data-oriented research will change this field. And with some opportunity, we get some sponsor, and we started this lab. And it turns out this trend really changed the whole research direction in the whole field. So, for example, nowadays in our group in mathematical finance in Oxford, there are about, I think there are more than half of our seminar are on those machine learning technology or data analysis and these applications in finance. And this is a big change. Yeah. Well, in fact, here, I don't think this kind of data analysis or data science is not only used in finance to deal with data, but also it changed the topic of our research, theoretical research. For example, in our lab, we have a project on the so-called behavioral finance. So this is trying to understand how people will behave, how people will make the decision in the real financial market. So those investors may not have their own analytical models to do the research. They will make the decision based on their experience.
Of course.
So we want to use the data of their investment strategy, the investment behavior, to trying to recover how they make the decision. So the decision making may not be as rational as we have assumed in the long history of the research. Some of them may not be rational enough. So we want to use the data of the behavior, decision making, or the behavior of investments to trying to figure out the preference, and hence we can understand more about how people will make the decision, and in consequence how the financial market will fluctuate, will change in some at least partially predictable pattern. So this is our research. Yeah.
That is fascinating. I don't think I am the first one to say this, but the stock market is really not about stock. It's about people, about investors moving money back and forth. And yeah, you're absolutely right. Most decisions are not rational. So trying to predict how the market will fluctuate over time based on those irrational decisions, which are essentially human decisions based on other things, feelings, as you said, and not only knowledge of your own local environment, but maybe not knowledge about the global environment. It's quite hard. That's a big challenge. Yeah. Hey, can you tell us a little bit more, and I will leave this open to either one of you, about the research that has been done over the past couple of years on the, with HPCC Systems on some of the impact of pandemic and other things.
Yeah, I think I can tell, probably I can say first, and maybe Hanqing will tell more about this. I think the original problem we collaborate with HPCC Systems, we're looking for some collaboration in the interdisciplinary area between behavioral finance, because Hanqing is mathematicians expert in these areas, and between behavioral finance and the data science. And we're trying to use some big data approach, trying to analyze the people's behavior, especially in finance, and how they are making decision makings, and what is the trading performance, and link with their trading behaviors, and to understand that kind of questions. And under that areas, we are working And we start a project called Alpha Trader. So it's kind of, if you know AlphaGo. So AlphaGo is a deep learning Go players, and we are trying to do something similar and looking for some alpha trader. So it's kind of a deep learning version of a trader, and we're trying to tackle the huge amount of big data in finance. For example, the transaction data, the trading data, and how the people buy and sell stock in the market, and also order book, limit order book. So limit book is how they place the orders, and also how trading transactions. And to analyze that, is there any patterns, and things we can learn and to understand. And then we're trying to develop some deep learning models, try to mimic, maybe partly, not fully, partly mimic or simulate some of their trading behaviors. And in the past 1 year, we are start with our first group. So first step, which is visual trading. So visual trading, if you're familiar with trading and professional traders, they have multiple screens in front of them. Normally 6 screens, some of them have more, maybe 8 or 10 screens. So each screen have a very important information. For example, the trends, the index, the news, and the holdings and the portfolios. And they use their visual systems, use their eyes, try to capture some patterns and see if they can get some signals from that pattern, from that screens. So it's kind of visual systems. It's very similar like to some visual, for example, facial recognitions and kind of systems. And we try to develop some systems like that. And we convert some traditional financial data into image. For example, the price of stock market, and we can turn in that to use some technical indicators, and also we can use some colors and turn that into image. And also, for example, limit order book, and we can turn the limit order book into some image, represent and buy and sells and different colors, and we use the deep learning algorithm, for example, convolutional neural networks, try to capture that patterns. And so far, we have some draft paper about it, and we develop algorithms can we test not fully because a lot of data. We only test 4 different stock, and the best performance we get, I think, is Amazon's. And Intel's. We can achieve more than half, which is 16% of accuracy rate, which is much better than the random guess. So this is kind of the first step. And because of pandemic, and we have been working at home since I think March 2020, and I've been asked by a lot of epidemiologists and also some doctors and to do some mathematical modeling in pandemic, especially to try to predict some, try to looking for some better mathematical models and try to tackle the problems. For example, lockdowns, because lockdown is a kind of a very hard decision to make, especially for the dilemma, because all the politician government, they don't want to impose lockdown. It's kind of a trade-off between the economic and the people's health. And you have to choose. It's a very tough decision, right? That's why a lot of, I just review paper today, that's why a lot of the countries in Western world, they are very delayed to make that decision because they put economic in first. And some country, for example, in Asia, especially East Asia, and they put the people's health in first. For example, at the moment, Taiwan, they only have a few hundreds case, and they impose lockdown straight away. But in UK, with the most time, the highest time we have maybe 13,000 cases per day, and so, and that's a kind of different story between the making decision. But it's a very hard decision to make. We are trying to use some mathematical models, for example, game series, and try to find the optimal ways and when and when is the best time to impose lockdown and how strong the lockdown should be. That is the problem at the moment. We are working at the moment, and we have already published one paper very early last year, and it's a kind of survey paper review all the mathematical modelings in these areas and in epidemiologies, and also the second paper is about our old papers where we have the mathematical modeling for lockdown, especially to try to use some game theories, optimizations, find the better decision making between lockdown, and we also want to maximize the economic and also try to minimize the impact of the lockdowns to the economic. And we just published a third paper, I think just last week. It's about vaccines. So we are looking for some optimal lockdown policies in the process of vaccine rollout, because I think this is a very critical time for most of countries. I think UK and the US is way ahead of the other countries. The UK is already vaccinating more than half of the population, and I think the US is still on the way. But a lot of countries are still very early stage in vaccination, and the problem is should you release the lockdown straight away after the vaccine, or when is the best time you can relax the lockdown? And we use some data and mathematical modeling, try to answer the question like that. I think Hanqing is a mathematician, and probably he can tell a little more details about that how the modeling works.
Yeah, especially this is now just an optimization problem, and when you say just an optimization problem, it's not just trying to trivialize it. I think it's a complex problem, is because it's not the more standard mathematical optimization where you have different dimensions that you are just trying to optimize for some variable. In this case, one of the dimensions is time. It's a time series, so that even adds, I think, another level of complexity, right?
Yeah. I just want to compliment with one point on our papers, especially the last two papers on the optimal lockdown policy. These two papers, this research are supported heavily by the HPCC system. On the data side, we use all estimation of our parameters are based on the data from HPCC system. And we had discussed the model or the formulation of our objective with colleagues from HPCC teams. So thanks also for all of them who helped our research. Yeah. So I think this kind of research, well, of course we can't make it very, very complicated because we think we like to capture the most important component in this kind of decision making. And if the government really think this is valuable, they can make our model finer, including more and more concerns into our model. But well, our research is just something like a baseline model for different people to look at the dealing of those the pandemic or epidemic in your local country or local area. Yeah. So the problem itself is well, in terms of mathematics, it's not that complicated. Although we can't solve the problem explicitly, like something like we give out a formula to calculate what is the optimal policy we should take at the current time, but we can use our simulation to calculate approximately what is the best decision we should make. Yeah. So this is about the control of pandemic. And I want to say we have another project on the on the problem I have described just now on how to find out or capture the preferences or the how people make a decision in financial markets. So that's that's related to the behavioral finance, and the PhD student who is supported by HPCC scholarship is working on this kind of work. We use the so-called inverse reinforcement learning technique, trying to elicit the preferences, different components of the preferences from real data and some simulated data. So I think this is also very interesting.
Did you, sorry, I know you may be curious as well. So did you find this problem, this optimization problem, a non-convex optimization type of problem where there are multiple local minima and the need to find that the global minimum that you need to optimize for?
We have not discussed the convexity. Well, this is a very a very professional question.
Very technical.
You can avoid the question if you want.
From you.
No, sorry.
Okay, so we haven't investigated this convexity problem, and but we believe this problem is convex. Hence the optimal solution should be unique, and in our numerical results, we search by iteration, and we find that the convergence is quite stable. So
and that is no matter where you start from, essentially.
Yes. That's good. So which sounds like the uniqueness is assured, but we have not proved mathematically yet.
Of course, yeah. No, and I am not expecting to do that on this call. Yeah. So I don't want to make this too long. I want to ensure that people can listen to the entire track. So it's just one final question. So how do I beat the stock market? How do I make money? Just kidding.
Well, academically, we don't suggest anybody to beat the market.
Very good. I like that.
because in most academic research, at least before the starting of our lab, we academic people believe the market is arbitrage free. That is to say, you can't bid for 100% sure against any people, even for some people who randomly make the decision.
But that's in the long term, and I don't want to get into it, right? So it's arbitrage free in the long term, but there might be local conditions that might give you ability to do arbitrage, but then they get diluted over time or over a larger.
That's right. Yeah. So over long term, you may have a big probability to beat the market. That's right. That is right. And in the other aspects, if we believe the people in the market is not rational enough, it is possible to beat the market or to beat some given trading strategy. That is possible, and we need to explore the irrationality and try to find out some pattern as a consequence of this kind of irrationality. Yeah, it is possible, and we need a lot of data to try to explore this kind of opportunity.
This is fascinating. I don't know. We could be talking for days. Unfortunately, we don't have the time, but this is really fascinating. It's a great topic.
Yes. And probably I can stay on the other side because Hanqing is too academic, and I think he is a strong believer of hypothesis of a computer market, which is assume when all the information is coming out, it will abstract straight away by the price. It's already reflected by the price, so you cannot find the arbitrage between. I think because the market is dependent on market, because the market change over the time, and now it's a lot of technology in the market. For example, quantitative finance use a lot of robots, bots are trading, I think I just read the article, 17% or maybe more, 17% or 18% of a transaction made by robots and not by human beings. So all the professional players in the market, especially in, I think the UK, US market especially, they're using robots. In that case, if you are retail investors or the individual players like you and me, you cannot beat robots because they are fast and they can make decisions very quick, and so it's a in very
They
short
will find
time.
that little arbitrage gap, and they will start
and
trading in milliseconds. So eventually,
they accumulate all the. That's how the institute make money. But the things happens last year because all the professional traders they lose money and individual players the big market. I think that's a very rare, very hard case because last year the market is very abnormal since the pandemic and the fact and so I think that's a very rare case. But statistically, if looking in long term, I think the better way for retail players at this time to beat the market is buy the index. I think the US, especially US for long term buy and hold, and all you can regular buy. And that's my strategy. I think for long term.
I think Warren Buffett is right there with you anyway.
Yeah, I think that's the best way you can make money. You can beat the market because all the index they optimize and they optimize the performance given the different stock. I think that probably is the best way and the easiest way. And if you want to trade by yourself and on individual stock, you need to be very careful because at this stage you cannot beat the robots, and they are very fast and they are very strong. And so I think that's my advice from my point of view.
That is great. So we come over. By the way, this is not financial advice. I want to make sure that nobody says that this podcast became.
That's from Warren Buffett, not from myself.
Of course. Thank you very much. So
thank you.
And Hanqing, this has been a great conversation. Thank you very much, and we'll stay in touch.
Thank you.
Thank you.
Cheers. Bye. Take care. Bye.